In this video, I will be solving problems from a quiz that I gave my class from the first half of their Similarity unit. Alright, so looking at problem number 1. Triangle KLM is dilated from the origin by a scale factor of 7 over 4. What will be the coordinates of point M prime? So first of all, point M is right here, and it has coordinates 4, 2. So if I want to find M prime, I need to multiply each one of these coordinates by 7 over 4. So I'm going to do 4 times 7 over 4 and 2 times 7 over 4. Well, these 4's just cancel, so that's just going to be 7. 2 times 7 over 4. So this is 14 over 4. Okay, which is the same thing as 7 comma 7 over 2. And this is the same, 7 over 2 is the same as 3.5. Okay, I mean, you could do 7 divided by 2 if you needed to. All right, so, wait, why is that giving me, oh, this must be set to give me whole numbers for some reason. All right, glad we fixed that. So let's try that again, 7 divided by 2. Okay, so anyway, the answer to that one is going to be A. For problem number 2, triangle PQR has been dilated from the origin to create triangle P prime, Q prime, R prime. Find the scale factor. So we can really just pick one point on which to focus. Let's look at point P, which became point Q. So point P is the point 3, 6. All right, and then that became P prime, which is the point 1, 2. So when you do your scale factor, which for some reason I always use K for scale factor, the scale factor is new over old. So in this case, the P prime is the new point, and P is the old point. So new over old. It doesn't matter whether you look at the x's or the y's, you should get the same scale factor. So if I just simply look at the x's, then new over old will be 1 over 3. So that should be the scale factor. So the answer should be B. All right, looking at number 3. Which of the following pictures show a triangle and its mid-segment? Well, a mid-segment is a midpoint connector. So that's one thing that I know about a mid-segment. So this is definitely a mid-segment because these are midpoints. You can tell by the double mark, and single mark, single mark. So I'm definitely going to circle this one because this is a mid-segment. Another thing we know about a mid-segment is that it will be parallel to one side of the triangle, and it should be half the length of the parallel side. So that means that this must be a mid-segment because it is both parallel and half of the parallel side. So this is a mid-segment. All right, this is definitely not a mid-segment because I see a 7 and a 14. Those are not equal. So these are not midpoints. Okay, so here, this is a mid-segment as well. All right, I see that they are, the two lines are parallel, and I see that we have midpoints. Okay, these are midpoint connectors. So I see 12 and 12, and also because of the 18, we know this will be 9. So it's really the same as number 1. that I can tell these are midpoints because of the markings are the same on either side. I can tell these are midpoints because the numbers are the same on either side. Okay, so midpoint connector, that's a midsegment. So that's number 3. Number 4, given these triangles are similar. All right, complete the similarity statement. Okay, first we need to verify which sides are corresponding. So to do that, notice that 44 is the smaller side. All right, on this triangle, 44 is smaller than 48. Notice that on this triangle, 33 is the smaller side. Okay, so that means that these must be corresponding parts, corresponding sides. And that means that these sides must also be corresponding. Okay, so obviously these angles are the same, these vertical angles are the same. But now I can see that angle C must correspond with angle D. All right, because both of those are connected to the double marked angle. Okay, and I can see that angle B must correspond with angle E because they are both connected to the box. Okay, so now I can do the similarity statement. Triangle ABC is similar to triangle A. All right, obviously goes with A. But B corresponds with E, so E should be second. Okay, and then C corresponds with D, so D should be third. Okay. Use the given information to find the requested angle measures. No work needs to be shown. Okay, so if the triangles are similar, all of the angles should be congruent. So let's use the similarity statement to see which ones are corresponding. So for example, A is first and P is first. So those are corresponding. All right, so A and P go together. That means angle P must be 61. All right, angle B and angle Q are in the same position. So B and Q are corresponding. Okay, so that means angle B must be 59. All right, that leaves angle R and angle C, which must be corresponding. And I can subtract from 180. So I've got 61 and 59. So if I start with 180 and I subtract 61 and 59, I get 60. All right, so angle C must be 60 and angle R must be 60. All right, number 6. All right, again, we need to match up corresponding sides before we really do anything else. So side DE corresponds to GH. All right, so DE corresponds with GH, so I'm going to circle those. All right, side EF corresponds with HI. All right, so EF corresponds with HI. Okay, that means that this DF must correspond with IG. Okay, so now I have all the corresponding sides. So now I'm going to set up an equation, a proportion, by doing new over old is equal to new over old. Now, when I'm solving for x, it doesn't matter which triangle is new and which one is old. I like to put my x's in the top for some reason, so I'm going to just pick this triangle to be new and this one to be old, but it doesn't matter. So let's see, so new over old. So I'm going to start off with 4x plus 8 because I'm trying to find x. So I need to do heart over heart. That's why I made these shapes. So I'll do 4x plus 8 over 24 is equal to, all right, and now I can really just pick any of the other sides. So for example, 15 over 12. All right, I just have to be careful to do new over old equals new over old, so 15 over 12. I like to reduce this fraction. That's not mandatory, but I recommend it. Okay, both of these are divisible by 3. So that's going to give me 5 over 4. You could also use your calculator. 15 over 12. Same thing. All right, so now we will cross multiply, which means we're going to take this diagonal and multiply those together and set it equal to this diagonal multiplied together. So in other words, I'm going to do 4 times 4x plus 8 is equal to 5 times 24. That looks like a z, but okay. I think I'm going to bring the work up over here. So, well, I can fit one more step down here. So this will be 16x plus 32 equals 120. Okay, if I subtract 32 from both sides, so I have 16x is equal to 88. And then I'm going to divide both sides by 16. So that is 5.5. All right, that was number 6. All right, there's a small typo in number 7. The angles should all be congruent. So if I subtracted from 180, this angle right here is going to turn out to be 61. However, so that would make angle B correspond with angle E. But looking at the similarity statement, angle B does not correspond with angle E. It corresponds with angle D. All right, so this 61 should have been over on angle D instead. So we really can't find Y because the angles don't make sense. So we're going to ignore that part of it. All right, so ignore the angles. In fact, just ignore all of the angles. And we will just find x instead. Okay, so let's match up our corresponding sides. So for example, AB corresponds to ED. So AB corresponds to ED. Okay, well, there's nothing there, but that would be that. And then BC corresponds to DF. Okay, so BC corresponds with DF. Okay, that leaves AC and EF. Okay. Now that I know which sides are corresponding, I can make my equations. So I'm going to make my equation of the form new over old equals new over old. It doesn't matter which triangle you call new, but I like my x's to be in the top, so I'm going to call this triangle new, and I'm going to call this one old. So that will give me x over 63, new over old. And then I can do the boxes, because I can't use the circles because this one's empty. But looking at the boxes, new over old would be 42 over 54. Now I like to always reduce this. So 42 over 54, that's 7 over 9. So I have x over 63 is equal to 7 over 9. So now we will cross multiply by multiplying these diagonals and setting it equal to what we get when we multiply these diagonals. Okay, so that will give us 9x equals whatever 7 times 63 is. 441. And then we divide by 9. And that's 49. All right, can't do anything about y. All right, number 8. Again, let's match up the corresponding sides. That's the key to a lot of these problems. So side AB corresponds with side DE. Those are blank. So, well, AB is blank. So, well, I guess I'll just follow through. So those are corresponding sides. Now, side BC corresponds with EC. All right, so BC and here's EC. All right, that means that these are corresponding as well. Okay, so now I'm going to set up my equation of the form new over old equals new over old. So in this case, it really doesn't matter which triangle I call new or old. They both have x's. So I'm just going to call this one new and this one old. But if you did it the other way around, you should get the same answer. So let's see. So that's going to give me 4x minus 4 over 5x minus 1. Okay, matching up the hearts. And then now I'm going to do the boxes. New over old, so 18 over 27. I like to reduce these. So that's 2/3. And now we will cross multiply. So we'll do this diagonal and set it equal to the other diagonal. All right, so that's going to be 3 times 4x minus 4 equals 2 times 5x minus 1. So that will give me 12x minus 12 is equal to 10x minus 2. All right, I need to subtract 10x from both sides. Okay, so that's going to give me 2x. So now I have 2x minus 12 is equal to negative 2. But then I need to add 12 to both sides. So that will give me 2x is equal to 10. And then I divide both sides by 2, and I get x equals 5. So that's number 8. All right, number 9. Once again, let's match up corresponding sides. So side AB corresponds with side FE. So here's AB, and here is FE. Okay, side BC corresponds with ED. Okay, so BC is right here. This would be BC, and ED is right here. All right, so they both have nothing. But then that leaves 60 and 8x plus 12. Those are matching up. Okay, so I'm going to do new over old equals new over old. Let's see. In this case, I think I'll call this triangle new and I'll call this one old. Doesn't really matter, but I like to put my x's on top. So 8x plus 12 over 60. See, I'm matching up the hearts. And then, okay, new over old. So 36 over 45. I like to reduce these. So that's 4/5. And then we cross multiply. Okay, so that means we will have 5 times 8x plus 12 is equal to 4 times 60. So this is going to be 40x plus 60 is equal to 240. Then we will subtract 60 from both sides. So that's going to give us 40x is equal to 180. And then we will divide both sides by 40. And that is 4.5. So now it's time to find angle Y. We would be able to find angle Y easily if we had angle A. If we had angle A, we could just subtract from 180. So let's find what angle A is. Now, using the similarity statement, notice that angle A corresponds with angle F. So those should be the same. So angle F is 98 degrees. That means angle A is also 98 degrees. So now we can find angle Y, well, angle C, but now we can find Y by subtracting the two of these from 180. So 180 minus 98 minus 52. So that's 30. So that tells us that Y is 30. Okay, triangle PQR is similar to triangle STU. They didn't give us a picture this time, so I guess we have to draw our own pictures. I'm going to cheat a little bit. Whoa, okay, got carried away there. All right, I don't know how this is going to turn out, so I'm just going to draw a roughly equilateral looking triangle. I'm going to make two of them. All right, let's use this. So I will call this one PQR, and I will call this one STU. Okay, PQ is 48. QR is 32. PR is 33. ST is 36. All right, now we are supposed to find TU. So let's just put an X right there. Okay, so we're just going to do new over old is equal to new over old. So I'll think of this one as new, and I'll think of this one as old. So that will give me X over 32 is equal to 36 over 48. I like to reduce these. So that's 3/4. So X over 32 is equal to 3/4. And then we will cross multiply. Okay, so I will have 4x equals whatever 3 times 32 is. And then we will divide by 4. So that's going to be 24. For number 11, Elise wants to enlarge a photograph that is 5 inches wide by 3.5 inches tall. So I'm going to let this rectangle represent the original photograph, and then we want to enlarge that. So I'm going to let this rectangle represent the enlargement. Okay, so 5 inches wide, 3.5 inches tall. The new triangle will be 8 inches wide. How tall will it be? Okay, so I'm going to do new over old equals new over old. So that will be x over 3.5 is equal to 8 over 5. So of course we're going to cross multiply. So looking at the first diagonal, that would be 5x. Looking at the other diagonal, this is 8 times 3.5. So 8 times 3.5 is 28. And then of course I need to divide both sides by 5. And that is 5.6. All right, so it will be 5.6 inches tall. Number 12. Joel stands 15 meters away from the base of a flagpole, which you can see right there. That is 12 meters tall. All right, that's 12. Joel's shadow is 2.8 meters long, which would be right here. And his shadow ends at the same place that the flagpole's shadow ends, which would be right here. How tall is Joel? So basically, that's X. So we should make two separate triangles. So that's what we're going to do. Let's draw a small triangle that's going to go like this. And then let's draw a larger triangle. And we will use these two triangles to set up our proportion. Okay, for the small triangle, I have X, which is what I'm looking for, and I've got the 2.8, the shadow. Now on the large triangle, this side is the flagpole, which is 12 meters tall. Now for the bottom side, I need to add these two numbers together. So that's going to be 17.8 meters. Okay, 15 plus 2.8. So now we can set up our proportion in the form new over old equals new over old. So I will have X over 12 is equal to 2.8 over 17.8. When we cross multiply, this diagonal will be 17.8x. Okay, and the other diagonal will be whatever 12 times 2.8 is. $33.6. And then we need to divide both sides by 17.8. Okay, so I'm getting this decimal. Did they tell us to round? Like 1.88, let's see, 1.888 if I round up. Okay, round to 2 decimal places if necessary. Okay, so that would be 1.89. 1.89 meters tall. All right, now number 13. Okay, pay attention to the order of the letters. So we need to draw the triangles separately. All right, so we have this small triangle. All right, and then we have the larger triangle. Okay, so on the smaller triangle, I see we have the X and the 54. So I will have X and I'll have 54. Now on the larger triangle, this 27 is not anything, all right? It's just a piece of the bigger triangle. I'm not going to use the 27. The 74 is the full side of the large triangle, so the 74 goes here. Now this side AD is the sum of 54 and 36. So that's going to be 90. All right. Explain why x is not simply half of 74. Well, anyone who thought that x would be half of 74 would be thinking about the mid-segment theorem, where if point C and point B were midpoints, then the mid-segment would be half of the parallel side. However, you see that we have 54 and then we have 36. So right away, point B is not a midpoint. So we cannot use the mid-segment theorem. All right, so there you go. Now we need to go ahead and find the value of x. So I'm going to do the old new over old equals new over old. So new over old would be x over 74. And new over old again would be 54 over 90. Now, some students do not like to reduce this fraction, but I find it easier if we use smaller numbers. So I'm going to reduce the fraction. So 54 over 90 is 3/5. So I've got x over 74 is equal to 3/5. So if I cross multiply, I'm going to get 5x from this diagonal, and 3 times 74. It's 222. Then I need to divide both sides by 5. $44.4. Okay, let's see, A, B, C, A, D, E. All right, finding the value of y. So this is going to be the same idea. Again, I am going to draw these triangles separately. All right, so looking at the small triangle, I see we have y and we have 54. And now, looking at the large triangle, got to be really careful. See the 74? That will go here. Now, what about this side up top? That's going to be the sum of both of these. So that is going to be 90. Okay, now this side right here is going to be the sum of both of these. So that will be y plus 27. So when I make my equation, and I am going to go new over old equals new over old, I will do y over y plus 27 is equal to 54 over 90. Okay, so y over y plus 27 equals, and didn't we already do this? Yeah, 54 over 90 is 3/5. So when we cross multiply, on this diagonal I will have 5y. On this diagonal I'm doing 3 times y plus 27. So that'll give me 5y is equal to 3y plus, okay, I'm distributing, so that's 81. Subtracting 3y from both sides, that will give me 2y is equal to 81. So then I have to divide both sides by 2. and that is 40.5. So number 15. In this diagram, HI is a mid-segment. So keep in mind as we do this problem that this mid-segment is half of this parallel side. So, or I could say 2 halves equal a whole. All right, so first of all, complete the similarity statement. Triangle EFG, all right, so that's EFG, is similar to triangle. All right, so just doing the smaller triangle in the same order will be IHG. Now, name a pair of parallel segments. Oh, that's what I just spoke of. So, segment HI will be parallel to segment EF. Okay, now given that FH and FH equals this and HG equals that, find the value of X. Well, those two things are up here. So here is FH and here is HG. So is this a half and a half, or is it a half and a whole? This is a half and a half, okay? Point H is a midpoint, so these are equal to each other. So I will just do 8x minus 2 equals 3x plus 8. All right, so subtracting 3x from both sides, that will give me 5x minus 2 is equal to 8. Adding 2 to both sides, I have 5x is equal to 10. And then if you divide both sides by 5, you get x is equal to 2. Next we have EF and HI. Well, EF and HI are these two parallel sides. So these are not equal. 2 halves will equal the whole. 2 times HI will equal the EF. Okay, so 2 times a half is equal to a whole. So 2 times the 3y minus 10, all right, HI was the mid-segment, is equal to 8y minus 80. So a little distributive property gives us 6y minus 20. Okay, so I think I will subtract 6y from both sides just to keep the y's positive. So then I have negative 20 is equal to 2y minus 80. And then I would add 80 to both sides. So that's going to give me 60 is equal to 2y. And then if I divide both sides by 2, I get y is equal to 30. And here endeth the lesson. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.